So this question is mostly about making insoluble salts. So I've underlined that, and I've underlined that it's by precipitation method. So a lot of the information I maybe don't need. I've got silver 1. 1 means it has a 1+ charge, although we would normally in our GCSE assume silver has a 1+ charge. It's the most common. Chromate 6, we don't need to worry about what that means. It just tells me as a chemist what the formula of this part here is, but you're given it so you don't have to worry. Basically, can you see they followed the same rules that if I want to make an insoluble salt, silver chromate, then I need something that contains silver, that is a soluble solid. So I would go for silver nitrate, make a solution, hence the aqueous part. And then, because all nitrates are soluble, to make a soluble chromate solution, I just need to go with one of the things that is always soluble. They've gone with potassium. We could also have ammonium or sodium there. That would all work as well. And we've got that aqueous. Then that's going to make a precipitate. So the two solutions mixed together will form a solid silver chromate because silver chromate is insoluble. Then we can filter it off and wash it and then leave it to dry in a warm oven. So the first question is not likely to be asked, but I will go through it. So the difficulty of the name of a compound of a transition element does not include its oxidation state. For example, iron oxide. So I'm going to use that example. And actually we have done two things to do with ions. In our testing for ions topic, we found out that iron could have a 2+ charge, but it could also have a 3+ charge because we tested for both of those. Now that's because it's a transition metal, and transition metals can have different charges. Oxygen though, when oxygen forms an oxide ion, it's in group 6, so it has to gain 2 electrons every time. So oxide ions will always have a 2- charge. So therefore, when I put these together, iron 2 oxide would just cancel out 2+, 2-, my formula would be FeO. But if I was to make iron 3 oxide, I swap my 3 and my 2 over, I would end up with Fe2O3 as my formula, because 2 lots of 3+ makes +6, 3 lots of 2- makes -6, so that's how I get my neutral formula with no charge overall. So that would be iron 2 oxide, that would be iron 3 oxide. So you can't just call something iron oxide, and actually that will come up next year when we look at rust. Okay, so A, bit of a side note, let's just get to B, because now we're talking about the preparation of the salt. Why is it necessary to filter the mixture? This is just to separate the solid or the precipitate. We need to get it on its own. What's the purpose of washing it? Is to remove other ions. You need to be really specific and not just say removes impurities. The other ions are going to be the things that are up here in solution, so potassium and nitrate present in solution. If we just filtered it and left it wet, then some of these potassium nitrate ions would be on there. So therefore we use pure water, distilled water, in order to remove the potassium and the nitrate ions. Why leave the precipitate in a warm oven? And that's just to dry the solid, or just to dry it, let it dry, because it's got water on it. We don't want to boil it, try and heat off, because it would probably decompose if we heat it over a Bunsen burner. It's only got a little bit of water on it. It would be very sensitive. Next one again is probably not going to be asked quite so much, but it's only based on a couple of topics ago when we did moles. The concentrations, which we haven't necessarily looked at yet, but 0.2 moles per dm cubed of silver nitrate. There's a 2 in front there. 0.1 potassium dichromate. There's nothing in front, which means there's one of those. So basically it's a mole question. So 2 moles of AgNO3 react with 1 mole of K2CrO for that thing there. And actually you could just say they don't react in the same ratio. Again, part II and III are calculation questions, but I'll go through them in case you've had a go and want to know whether you're right, although we haven't actually done moles per dm cubed yet. But if it's 0.2 moles in a decimeter cube, then in 100 centimeter cubed, which is 1/10 of that, then it'd be 0.02 moles. And I want silver nitrate. The mass of 1 mole is 170, so I'd 0.02 times 170, and that will give me 3.4 grams. Maximum mass of silver chromate, which could be obtained from 20 centimetres of concentration 0.2. Again, we haven't done these concentrations, but in case you're looking at this in the future, then 0.2 times 0.02 would give me 4 times 10 to the minus 3. Number of moles of that would be 2 times 10 to the minus 3. The mass of 1 mole is given to us, so I would just times it by that and I get 0.664 grams. But that's ahead of the game, that question. Okay, so don't worry about part C.